Hello everybody, my name is Karl and I am a master trainer in EduBridge Learning Private Limited. So I welcome you all to this online learning with EduBridge. So today's session is going to be interesting. So today we're going to learn about permutation and combination and types of permutation. And also we're going to learn about different types of questions that you will get in your online aptitude test. So why are we waiting? Let's go to the session. So now we're going to discuss about the types of permutation. So before that, if you are new to our channel, right, I just want you to subscribe and like the button which is there down below. And we have already uploaded a video on permutation and combination and its method and its concept also, right? I just want you people to watch that video and then come back here, right? So now we're going to discuss about the types of permutation, and we have two types of permutation. So one is linear, and we have linear over here, and then we have in linear we have word permutation and number permutation, and we have another one which is circular. Circular, we have two types. It's a general circular type, and the other one is Garland type, where you will be getting a questions on the basis of necklace type of question. So these are the four types of questions we're going to discuss today. Let's solve this question. So this is a question from word permutation. The question is, in how many different ways can the letter of the word, right, optical, be arranged so that the vowels always together? So look at the word, it is optical. So as you all know that vowels. So what are the vowels we have here in the word optical? So we have three vowels. What are they? O, I, A. So O, I, A are the three vowels that we have here in the word from the word optical. And what are the other letters? The other letters are P and T and C and L. So here, how many ways I can arrange so that the vowels always come together? As you all know that vowels are O, I, A, right? So here, before we solve that question, so we have to know about how many total arrangements are possible from this particular word optical. So how many arrangements possible? So we have 1, 2, 3, 4, 5, 6, 7. 7 letter. It's a 7-letter word. So the total arrangement, total ways of arrangement possible for this particular word is 7 factorial ways. Yeah, 7 factorial. So in this, OIA is a vowels. So vowels together. So that can be arranged in 3 factorial ways. Isn't it? 3 factorial ways it can be arranged. And here, how many letters? This OIA can be formed in here, here, here and here. That can be arranged in a different way. So here into how many ways that OAA can be placed? So that can be placed in 5 factorial. So vowels together, which is 3 factorial into 5 factorial. So what is 3 factorial? 3 factorial here is 6, 3 into 2, and 5 factorial is 120. So 6 into 120, my answer is going to be 720 ways I can arrange the word optical, right? So that the vowels always come together. Let's see the next question from number permutation. So the next type that we are going to discuss is number permutation. So right now I have a question from number permutation. Look at the question. How many 4-digit numbers can be formed from the digits 0, 1, 2, 3, 4, 5, 6, right? So I'll repeat the question. How many 4-digit numbers can be formed from the digits 0, 1, 2, 3, 4, 5, 6? So this is a part of a number permutation question. So here, whenever we are discussing whenever we are solving a question in number permutation, we have to keep one thing in mind, that we have two types of number permutation question can be solved. So first type that we have here is with repetition. So WR, with repetition. The second type is without repetition. So without repetition, I write it as WOR, without repetition. So now look at this. I want what? I want a 4-digit number. How many digit number? I want a 4-digit number. So I'm going to put a 4 lines over here, 4-digit number. And how many digits I have? 0, 1, 2, 3, 4, 5, 6. So these are the digits that I have here. So what I can do, look at this. First digit is 0. So can I place 0 here? If I place 0, what it becomes? It becomes a 3-digit number. So that is not possible at all, because I want a 4-digit number. So I cannot place 0 in the first place. So now what I can do, instead of 0, I can put any other number. So what is that any other number here? So I can place 1, 2, 3, 4, 5, 6, any other number. But I should not place 0 in the first place. So how many remaining numbers can be possible? So 1, 2, 3, 4, 5, 6. How many numbers I have? I have what? 6 numbers here. Yeah, I have 6 numbers. So the first place, how many numbers I can place? 6 numbers I can place. And you all know that this is a with repetition type. So the second place, I can put the same number. If I put any number, for example, if I put 1 here, I can put 1 also. If I put 4 here, I can put 4 also here in the second place. So that's not a problem over here. So in the second place, how many numbers I can place? I can place 7. In the third place, I can place 7. In the fourth place, I can place 7. So which means, so 7 cube into 6. So 7 cube into 6. Thus that is the number of ways 4-digit number can be formed from the digits 0, 1, 2, 3, 4, 5, 6 with repetition. So with repetition, what is that? 7 cube into 6. 7 cube is what? 343 into 6, which is 2058 will be your answer. Right? So okay. So next type is what? Without repetition. So without repetition means what? The name itself tell you. So it should not repeat. So how many digits I have to find? I have to find a 4-digit number. I have to find what? 4-digit number. So in this 4-digit number, again, I cannot place 0 in the first place. Why? If we place 0 in the first place, then it becomes what? It becomes a 3-digit number. But I don't want a 3-digit number. What I want a 4-digit number. So here, except 0, I have to place all other numbers. So I can place all other numbers. So 6 numbers can be placed in the first place. Right? So here, into multiply, and then the second place, how many numbers I can place? Now here I can put 0. Yeah, that's not a matter at all. So here if I put 0 also, right, but some other number I would have put. For example, right, if I put 1 over there in the first place, except 1, the remaining number I can place it over here. Except 1, 0, 2, 3, 4, 5, 6. So how many numbers I have here? So I have another 6 number. So 6 into 6. So already 2 numbers I placed. So how many remaining number I have? I'll be having 5 numbers, right? So 5 numbers. So 6 into 6 into 5 into 4. Why? Because this is without repetition. The number should not repeat. You got it? So what is the answer over here? So 6 into 6 will be 36. 36 into 20. My answer would be what? 720 ways I can able to form a 4-digit number from the digits 0, 1, 2, 3, 4, 5, 6 without repetition. So these are the important 2 types, with repetition and without repetition, that comes under number permutation. So the next type that we're going to discuss here is circular permutation and Garland permutation. As I already told you about the linear permutation in the previous video that we uploaded, right? So here, what we're going to do is, right, we're going to discuss the same thing but in a different way. So in linear permutation, if there are 3 people, let's say A, B, C, 3 people are arranging themselves. How many ways they can able to do it? Yeah, so they can able to do it in 3 factorial ways. 3 factorial ways, which is nothing but 6 ways they can able to arrange themselves. If you have a doubt, what are those ways? ABC and ACB, BAC, BCA, CAB and CBA. So this is a linear arrangement for this. So totally how many ways? 1, 2, 3, 4, 5 and 6. 6 ways they can able to arrange themselves in linear. Now This is in circular, means how many ways we can able to arrange them. Now, it is a circular arrangement. So let's do this. Circular, right? In circular arrangement, so I'll make the circle a little smaller now. Okay, so that it will be easy for you to see it. So a smaller circle, you have A here, and we have B, and we have C. A, B, C, one arrangement, and another arrangement. What is this? A, C, B. So A, C, and B. Another arrangement, and one more, right? We have what? BAC, B, A, and C, BAC arrangement, and then BCA, it is B, and we have C and A, BCA arrangement. We have two more. What is that? CAB. So that we have C, and we have A, and then we have B, and here last arrangement, which is C, B, and A. So how many different circular arrangement possible? I know that you are saying 1, 2, 3, 4, 5, 6, isn't it? Right? But that's wrong. Why? I'll give you a little clarity about this. Look at this image little closer. It is A, B, C, right? So A, B, C, look at in this way, clockwise direction, right? This is nothing but what? It's a ABC arrangement. Yes or no? ABC arrangement. Done. When you look at this one, it is what? In a clockwise direction, it is A and C, B, ACB arrangement. What is that? The second type, ACB arrangement. Now, look at this one. In a clockwise direction, you might be saying that it is BAC, which is nothing but again ACB arrangement, isn't it? ACB arrangement, which is same like this ACB arrangement. So this is an ACB arrangement. Yeah, look at this one. It is BCA. You think this is different arrangement, but that's not. Look at closely again. This is the same arrangement as ABC arrangement only, right? And look at this one also. So in a clockwise direction, if you look at that, so this is a ABC arrangement, ABC. This is also a ABC arrangement, and here the last one, which is ACB arrangement, So how many different arrangement possible in circular when three people sitting in a circular table, which is only two, which means that I can say that n minus in circular n minus 1 factorial ways can be arranged. For example, if it is linear, if it is n factorial ways, it can be arranged, which means 3 factorial, it's 6 ways, means here in circular it is n minus 1 factorial. Let's give you another question on this. In circular permutation, let me ask you a question. There are 5 people. How many people? 5 people, right? Let's take like K, L, M, N, O. So K, L, M, and O, 5 people sitting in a dining table. How many different arrangement possible? Very simple. How many people are here? 1, 2, 3, 4, 5. So 5 people. So n is what? 5. So n is 5. Which means if they are sitting in a circular table, how many different arrangement possible? Which is 5 minus 1 factorial ways arrangement or possible, which is nothing but 4 factorial ways I can arrange them. 4 factorial is what? 24 ways I can arrange them. You understand? So one more question I'll give you. There are 11 players in a cricket team. How many ways I can arrange them? A simple question. There are 11 players in a cricket team. They are attending a simple conference about the cricket match. How many ways I can arrange them? It's a circular conference table. How many ways I can arrange them? So 11 is n. So 11 minus 1, which is 10. So 10 factorial ways I can arrange them. You got it? So this is a type of circular arrangement. Let's discuss the same thing, which is slightly different in garland arrangement. I'll erase this one and we'll go a little further. So here in garland permutation, which is also follows a similar type. So n minus 1 factorial. But here it is in a clockwise and anti-clockwise direction. For example, Garland permutation, which is also called as necklace type. So this necklace type, remember, look at this. There is a necklace where you have identical beads. How many beads? You have 5 identical beads. So it is a circular arrangement. Ultimately, it's a circular arrangement. So how many ways I can arrange them? Which is 5 minus 1 factorial ways I can arrange it. But here, since all these are circular, identical pearls, let's take as a pearls, right? All the pearls are so identical. If all the pearls are identical, there is 2 different same arrangement possible. One is from the clockwise direction, another one is on anti-clockwise direction. So I want to eliminate both the arrangements, both the false arrangements. So what I have to do to eliminate a false arrangement? So I have to divide by 2. So from this you can make a formula for Garland permutation or necklace permutation, that n minus 1 factorial by 2. So if it is 5 beads, 5 pearls in a necklace, how many ways I can arrange it? 5 minus 1 factorial by 2. That is what my answer. Let's imagine there are 7 identical diamonds which is placed in a necklace. How many ways you can arrange it? I hope you are saying it. Yeah, very good. It is 7 minus 1 factorial by 2. That is your answer. So these are the types of permutation question. So what are the types? So far we saw the types of word permutation, we solved the question on it, and number permutation, we solved the question on it, and we saw the different types of questions from circular and linear. And don't forget the formula. What is the formula? So n minus 1 factorial for circular and n minus 1 factorial by 2, that is for Garland permutation. So thank you so much guys for your support, and don't forget to like the video and subscribe our YouTube channel. Thank you so much, and I am signing off, Karl Indian from EduBridge. Bye bye.